Good day, everyone. Thank you for joining us today for the Flow Waterjet online trade show. This is our third webinar in the series, How to Choose and Use the Right Pump for Your Waterjet. And we really appreciate your joining us today. We will be getting started momentarily. Just a few housekeeping notes for you to keep in mind. My name is Steve, and we are live. So to help minimize any confusion, we have muted everybody's microphones and cameras so we can't see or hear you. However, you can, and we encourage you to send in any questions you have during the presentation by using the chat box, which is on the right side of your screen. So if you could kindly include your name, we will be able to follow up with you afterwards in case we don't have time to get to your specific question during the webinar. Second, we expect the content portion of the webinar to run for about 35 or 40 minutes, and then that'll leave us about 15 or 20, give or take, for Q&A. We certainly hope you'll stick around for the Q&A because we do have some special offers available if you are considering looking at a new pump or a new system, and we don't want you to miss out on that. There's some great opportunities to save. And also, if you cannot stay for the full show, no problem. We will be sending a follow-up email within 24 hours of the end of the webinar. And in that email, you'll get a copy of the presentation as you'll see it, our contact information, as well as a link to the recorded version of this webinar, along with all the answers that were, or all the questions that were asked and the answers during the presentation, whether we got to them or not. And finally, we are on a platform that works best with Google Chrome. So if you're having any technical problems, we recommend logging out and logging back in. And you should be able to cut and paste the link and use Google Chrome if you have it. And that should give you the best performance. But then again, if there are any issues, we will be following up with a copy of everything that happens today, so you won't miss anything at all. Please feel free to ask questions throughout, as mentioned in the chat box. We welcome that anytime. And if you would like someone to contact you immediately today, feel free to include that in your message, and we will make sure that happens. So what I would like to do now is introduce you to your presenters for the day, Jesse Tilley and Evan Washington. They're presenting to you today from our Southwest region, where Jesse is our regional business manager. Evan is our applications engineer. Don't let their youth and good looks fool you. They have a combined 30 plus years of experience in this space. They could not be better representatives of Flow, not to mention subject matter experts on this very important material. So, gentlemen, if your cameras are on, I will hand it over to you, and let's get started.
Yeah, thanks, Steve. And certainly thank you, everyone, for attending. I think this will be a really helpful thing. You know, as we've gone through and done a series of webinars, and we have more coming, you know, the idea is really that your Waterjet's a completely integrated system. You know, you have all these different components, the cutting head, the motion system, which one of the Mach series machines is the right fit for you? Do you need 5-axis capability, all these different things. Today, we're going to talk about the pump. And so the pump is really kind of the heart of your Waterjet. We're in a really good position, you know, on this call to be able to speak to you guys about all the different pump technologies. You know, we're really agnostic about it. We have the unique capability where we offer, you know, 55 and 60K direct drive style pumps. We have 60K intensifier pumps, as well as the kind of production style, real high end 94,000 PSI hyper pressure pumps. So it's really not super important to us what pump you buy. The important thing is helping to dial in which pump is going to be the right pump for your application and for what you're doing. And, you know, make sure that you're just getting the right pump. That's what we're really hoping to dial in here today. So when we talk about the different types of pumps, there's two main families of pumps. You've got your direct drive pumps, which is this graphic that's on your screen here in the lower right-hand corner. This says Hyplex Prime. That's a direct drive style pump. Behind it is an intensifier style of pump. That one happens to be a Hyperjet, one of our higher pressure units. When you look at this graphic on the lower left, what you see is that direct drive pumps, kind of just the technology, is they're really limited to about 55,000 PSI. Intensifier pumps, everything that's commercially available right now, is going to be kind of right in that 60,000 PSI range. Intensifiers, though, also have the unique ability to run at much higher pressure. So you can get an intensifier at 60,000 PSI, or we offer intensifiers up at 94,000 PSI. And this is kind of where everything in the market is at right now. If you were to, go back, 30 or 40 years to when Flow actually invented the technology of abrasive water jet cutting, you'd find that these pumps were all running at much lower pressures, 35, 40, 45,000 PSI. So the general trend in the water jet industry is that you always want to increase your pressure. And so kind of where we're at today is pressures between 60 and 94,000 PSI. Certainly the expectation is in the future we'll get up into even higher pressures. So they're all really good pumps. We've got guys with direct drive pumps that have been running them for 10 years and they absolutely love them. They do everything they need that pump to do. And it's a great machine and they couldn't be happier. We've also got guys with 60,000 PSI pumps. That's the pump in the middle here. Again, great pump and does everything they need to do. And then depending on application, for some guys, the 94,000 PSI pump, kind of the highest pressure, fastest cutting production style pump, is really what they need. And those guys are happy as well. So they're all really good pumps. It's just a matter of figuring out what is the best pump for you. So as we dig into this, I think a really good place to start is, how do these things work? When you look at the internal mechanicals of these things, what makes a direct drive pump and an intensifier pump kind of function? Evan knows this stuff really well, and he'll be able to kind of take us through that.
Yeah, thanks, Jesse. So it's really important to understand kind of how they work. That'll help you in your decision when it comes down to choosing the right pump for you. We'll kind of go over an overview of that. So direct drive pumps, they make up about 20% of the systems worldwide. They're most commonly found in, other applications such as paint removal, mining, industrial cleaning, and spraying. So they're really simple. You can kind of think of them as a pressure washer on steroids. Here in this picture, you can see there's a crankshaft. This is kind of how the direct drive gets its name. So the electric motor connects to the end of that crankshaft there, and it directly moves those plungers through that crankshaft. So that's kind of the cutaway version there, and we're going to jump into a video here that kind of further explains how that works. So a direct drive pump uses an electric motor, like I said, to turn a crankshaft, and that crankshaft moves 3 pistons quickly, right around 1,200 strokes per minute, to intake and pressurize this water. So this is about 20 times faster stroke rate than an intensifier. So as you see, it's pulling the water in and then it's moving. So you have 3 pistons. Each one of those are moving really quickly. And since they're moving so fast, there's no need to try and balance out that pressure. It's going to come out balanced at the end. It then goes through a check valve and heads out to the cutting head. So the Hyplex Prime, so that's one of our direct drive pumps that's suited for a Mach 100, Mach 200. We do put them on other machines like the 500 and 700 and 300 as well. But most commonly, we put them on the Mach 100s and 200s for a number of reasons. One just being, relatively low usage, or if you're, you have a situation where you're, kind of bound by a budget, these are less expensive pumps to buy up front, so less upfront cost, but they're great pumps. So some of the benefits to direct drive pump is they're, electrically, they're efficient. There's no hydraulics to, zap any of that power. The electric motor, like I said, directly moves those, the crankshaft and those pistons. It's compact in size, so floor space is really valuable, and you need the smallest possible configuration. Direct drive pump is a good fit. They're also less expensive, like I said, up front, and there's no additional cooling water needed to cool off any hydraulics. So intensifier pumps, they're the original and most common technology used in waterjet cutting by far. Their intensifier pumps use, basically they intensify the water. That's where they get their name, and we'll dive into that here. So the intensifier uses hydraulic fluid to move two pistons, also known as biscuits, kind of back and forth to amplify or intensify the water. Hence the name intensifier pump. And in 60,000 PSI pump, it would have 3,000 PSI of hydraulic fluid, which you can see there in the brown, which in turn at a 20-to-1 ratio intensifies through that biscuit the water on the other side. So it's pulling water in as it goes to the left, and as it goes back to the right, it's pressurizing the water, and vice versa. Here you can see the water coming in as well as the high pressure water coming out. So since this is stroking at about 60 times a minute, about 20 times less than a direct drive, it comes out in spurts. And as it comes out in spurts, it needs to be sent to a pressure vessel, and that pressure vessel essentially balances out the pressure to the cutting head. So some of the benefits to an intensifier: improved maintenance intervals, better suited for applications with many on-off cycles, because the intensifier has the ability of basically stopping its shift in order to prevent additional water pressure. Faster and simpler rebuilds, fewer failures and downtime, and not limited to 60,000 PSI. We can reach pressures of 94K with an intensifier. And one of the other great things is in this picture here on the left, you can see this is actually a dual intensifier pump here, but those intensifiers can be removed, and that's where a lot of your rebuilds will happen. So if you need to, rebuild your pump, you can essentially pull that intensifier off and put one that's already rebuilt back on, allowing you to continue your production. So if you're in a situation where you need to have maximum uptime and throughput, the intensifier swap takes 20 minutes. It's just a high pressure line, low pressure line, and 4 bolts, and you're back up and running. So it's really quick to get back online. So typically we see 60K intensifiers matched up with our Mach 300 and 500. Again, we do put intensifiers on 100s and 200s. That's also pretty common. But once you get into production, tighter tolerances, that's where, it really becomes valuable, to spend that little bit extra money to move to an intensifier so that you can maximize your uptime. And, those you typically match up with higher tolerance machines. So Hyperjet, this is our 94K intensifier. These are typically on 300s and 500s. Again, down to tight tolerance, and then also maximum uptime, maximum throughput. And, if you're going to be running 2 shifts a day, cutting a lot of parts, it's really important to be able to, quickly move on if you run into a situation where you need to rebuild the pump. So what does that all mean in terms of pressure? We were talking about, there's 60K, there's 94K. How does that, impact, your cutting, and how is that going to affect your finished parts? So I'll let Jesse talk to us a little bit about that.
Yeah, thanks, Evan. So, the pressure is arguably the most important thing to kind of pay attention to with a water jet pump. We've talked about these different pressures, but what are the benefits, drawbacks? Why would you want a higher pressure? The first thing is, let's look at kind of the industry defined pressure levels. So, 10,000 PSI over on the left is considered to be low pressure, 10 to 15 medium, 15 to 40 is high pressure. Something worth noting is that, years ago, again, about 40 years ago, when Flow invented the technology of abrasive water jet cutting, this is kind of where the market was at. 40,000 PSI pumps, maybe getting into 45,000 PSI early on, and the pressure has always been increasing. Nowadays, what you see most common for water jet cutting is, the 40 to 75,000 PSI range. That's referred to as ultra high pressure. And then 75,000 PSI or higher is what gets referred to as hyper pressure. So that's kind of the definition of the different pressure levels. So a direct drive style pump, like what we've been talking about, kind of the kind of standard or basic style of pump, those are all going to run, they can't exceed 60,000 PSI. It's just kind of a physical limitation of the technology. So those pumps are kind of going to be mostly in the 55, 60,000 PSI range, for a direct drive pump. Some intensifier pumps are in that level as well, but intensifier pumps also give you the ability to go up to 94,000 PSI. So, hyper pressure technology, that's something that's going to be unique to Flow. And we're really proud of that. It's, really going to help you out with the production levels. And if you really need to focus on maximizing throughput, minimizing costs, the hyper pressure technology is kind of where most people are going to end up heading. The kind of simple, the fact of the situation is that pressure ultimately equals productivity. So as you go up in pressure, you're going to cut faster. You're going to use less garnet abrasive. So, and that's kind of your big operating cost with a water jet. If you're looking at your operating cost of a water jet and, your air, your power, your water, your spare parts, your pump seals, your garnet, that garnet, the cost of buying the garnet and disposing of the garnet represents about 2/3 of your operating cost. So you're using less garnet, and that's kind of the key to the whole thing, and why the pressure goes up is you want to use less garnet. You cut faster, you use less garnet, and that's what contributes to you actually having a lower cost per part. And as you can imagine, if you're, in the business of really high production, trying to cut a lot of stuff, that's kind of the name of the game, is how do I make these parts faster and cheaper? So with the hyper pressure being defined as any pressure over 75,000 PSI, what you're really trying to do there is, as your pressure goes up, the velocity of that stream of water coming out of your cutting head increases as well. So, at 60,000 PSI, that stream of water is moving about 3 times the speed of sound. You get up to 94,000 PSI, you're approaching 4 times the speed of sound. It's a very fast moving stream of water. And that water is really there just to accelerate the abrasive particles. So as that stream of water is moving faster, every particle of abrasive, every particle of garnet abrasive that's in that stream is also moving faster. And so now when you're going to cut your part out of your 1/4-inch aluminum or whatever it is, every particle of abrasive is moving faster, and that causes it to remove just a little bit more aluminum. So it's really, how do you get that abrasive? How do you get every individual particle of abrasive to do more work for you? And the only way to get it to do that is to get it to move faster. And that's why you increase the pressure. So another benefit is when you increase your pressure, you actually end up with a smaller, faster moving stream of water and garnet. So a lot of times when you go from, say, 60,000 PSI to 94,000 PSI, you'll actually decrease your stream diameter by about 25%. And so that'll allow you, now that you have kind of essentially a smaller tool, you can cut more detailed parts, sharper corners, finer lines. And a lot of times that's what allows you to get access to certain work. If you're doing contract work, that's what allows you to go after that work. If it's internal stuff, it's just more jobs that the water jet can accomplish with a smaller stream of water and sand doing the cutting. So if you look at this chart on the left, what we're kind of trying to show here is that at 90,000 PSI, you're typically going to have a stream width of about 30 thousandths of an inch. If you were to go down to 60,000 PSI, that stream actually gets wider. It's about 45 thousandths of an inch. And this really gets to how much detail can you cut? How wide is your tool? So at 90,000 PSI, 30 thousandths of an inch goes up to about 45 thousandths of an inch. At 60,000 PSI and 40,000 PSI. And again, this is a pressure we haven't, no one's really ran at for years. But back in those days, the best detail you could get is you were working with something like a 60 thousandths wide diameter. And so, I know that a lot of guys on this call are probably familiar with lasers. With a laser, you always want to increase the wattage. The wattage goes up and up and up and up, and that's how you cut faster and you're more productive. With a CNC miller lathe, you increase spindle speeds, and as those spindle speeds go up, you cut faster. Well, with water jet cutting, as the pressure goes up, that's how you cut faster and more efficiently, and that's been the trend in the industry since the very beginning. So this is a really good video where we've basically done an overlay. We've ran a machine at 90,000 PSI, then we took the pressure down to 60,000 PSI. We've kind of done an overlay here to where you can see both cutting heads. And what you're going to find is that the 90,000 PSI pump really starts to pull away from the machine that's set up to run at 60,000 PSI. So you can see, the 90,000 PSI pump's now done cutting the circle. The 60,000 PSI is still coming around. We're going to transition over and cut the exterior of the part. And the 94,000 PSI really cuts quite a bit faster. So, these are kind of the differences you see if you're looking and watching it cut a single part. As you can imagine, if you're cutting an entire sheet of parts, this is something where, the 90,000 PSI is getting your whole sheet done in an hour and a half, and the 60,000 PSI pump's taking 2.5 hours. So if the goal is to get as many parts off of that machine as possible in a day with the lowest cost per part, that's really where the 94,000 PSI pump is going to make sense. But a key takeaway as well is at the end of the day, this 60,000 PSI pump is going to cut a great part. You're not going to be able to tell a difference in the finished part between the 60 and 94,000 PSI. So if you need to get 3-4 parts off in a day, a 60K pump is going to work great for you. But if you need to get as many parts as possible off in a day, that's really where the 94,000 PSI pump starts to make sense. So again, it really gets back to your application. So one question and things that come up a lot, and I'm sure a lot of folks on this conference here have done some research online. You see a lot of stuff. What about horsepower? So that's one of the things that comes up a lot. What if instead of increasing my pressure, I just increase the horsepower? And that's a really good thing to bring up. And I should mention as well that we make pumps at a whole lot of different horsepower levels as well. The main thing with horsepower, though, is that as you increase horsepower, your costs go up accordingly. So you double your horsepower, you're doubling your operating cost. When you increase your pressure, your operating costs go down. So that's why we're not running at the 40,000 PSI pressures, that were common, 30, 40 years ago. The secret isn't to increase horsepower. That's not what you're trying to accomplish. That will help, and that's certainly part of the equation. And that's something that we can speak to. We've got 20 applications guys like Evan and myself that know this technology really well, spread around the country. And, I know Steve will mention it kind of towards the end of the call, but, don't hesitate to reach out to us. That's what we're here for, is to have conversations. We can visit you in your shop if you want, help you dial in everything that's right for you. But, kind of the short version with horsepower is you increase horsepower, you increase operating cost accordingly. When you increase pressure, you decrease operating cost. And that's what you want to do to remain competitive. And raising that pressure is really what increases that efficiency, like I was speaking to here. So you can kind of get into the formulas and the scientific side of this. The idea here, though, is you want to increase your power density. So like we talked about, your stream of water is, larger at 40K, smaller at 60, even smaller at 94. You're creating a certain amount of power from that pump, kind of the electric horsepower and the pressure. If you spread all that power in an area this big, your power isn't real dense. You get down to 60,000 PSI, now you're spreading that power amongst a smaller area. 94,000 PSI, even a finer area. It's kind of a similar concept to wanting a knife that's very sharp, or a thin saw blade. It's going to be easier to cut through something with a thin saw blade than a really wide saw blade. It's going to be easier to, cut your steak with a sharp knife than a dull knife, because that sharp knife focuses all that same amount of power on a very sharp tip instead of a dull tip. And it's a similar concept with water jets. So, when we talk about pressure equals productivity, the jet velocity, again, is really the key. You want to increase the velocity of that stream of water to increase the velocity of the garnet abrasive, so every particle of garnet does more work for you, because that's your big operating cost. That's what you're chasing, is how do I get my operating costs down? You're focused on the biggest of your operating costs, which is the garnet. And the way to get that garnet cost down is to use less. And you got to get it moving faster to use less of it. And the only way to make that stream go faster is with higher pressure. So higher horsepower has its benefits, but you're not going to get that stream to move faster. You're not going to get your operating cost to decrease. So, and every pump has a maximum operating pressure. So, you can't tweak something on a 60,000 PSI pump and get that stream to move faster. 60,000 PSI water is only going to move so fast. you get up to the 94,000 PSI, and now you really increase that velocity. So a lot of this stuff is maybe, you know, kind of somewhat theoretical or technical at this point. I think at least what kind of really helps me to understand something is, you know, what's a real life example? Where's a situation where this really made a difference? Evan recently spent a lot of time with one of our kind of long-term partners up in Nevada that really was kind of weighing the options. They spent a lot of time doing an analysis of what was the right machine for them. And I think it really kind of brings home these points we're talking about. Evan can kind of talk us through that here.
Yeah, thanks, Jesse. See, I worked with a team. It's a company, American Team Finish. They bought a Mach 200 with a 60 high-plex pump back a few years back. And, you know, they're a small shop. They bought it mostly for their own work. They do a lot of tile, flooring, countertops, stuff like that. As they, you know, own this Waterjet, after a short period of time, they started getting a lot of inquiries for contract cutting. And they saw there's quite a bit of room for making some money in the contract cutting side of things. And that worked out great. They were cutting their own parts and they were doing some contract work on the side in between. But they finally reached a point where they, you know, had enough work between contract cutting, their own work, that they were getting to a point where they might have to actually start turning some jobs, and they could work on a second shift or add a third machine, but none of those options really worked. They were limited on floor space and really didn't want to have to add a whole second shift. So we kind of dug into the details, and we kind of went through some of the differences between, you know, a 60K pump and going up to a 94K pump, and replacing that Waterjet. So we're actually able to work out something where they traded in their Mach 200 and they actually went to a 500. And some of the reasons they went that route was they were able to complete more work in the same amount of time. So, you know, it's 30 to 50% faster cutting depending on the parts. And that also allowed them to lower their operating costs, so they could be more competitive. They didn't have as much abrasive use, which means they didn't have to empty out the tank as often, which means they were down less. We were able to take advantage of the Mach 500's higher accuracies and tighter tolerances due to a smaller kerf width. So they saw that being the best option. They didn't have to go to a bigger shop. They didn't have to do anything like that or ask that second shift. And yeah, it was a really great scenario, and it worked out for American Team Finish very well. So here's the part that we cut. You know, it's a 1/4 inch aluminum. This kind of gives you a good idea on kind of abrasive usage and total cost. So it's 40 total inches to cut this part. And we cut it with 60K, we cut it with 94K, and you can see the difference in abrasive use here. So the 60K to cut that part, and it was 1.75 pounds of abrasive versus 1 pound of abrasive on the 94K. The cycle time went from 1 minute and 30 seconds down to 50 seconds, hence lowering the cost per part from 62 cents to 30 cents per part. So, if maximum amount of parts, like Jesse was saying, getting those off the table and turning as many parts as possible is the goal, then 94K really starts to make sense because it does lower your cost per part. And this slide does a really good job kind of showing the differences between the two. So how do you know which pump to choose? So, as you're taking in all this information, and you're kind of looking at all this stuff, how do you know which pump to choose? So when to use a direct drive? So are you planning to only operate for a portion of the week or a small number of shifts? Simpler, it's simpler, more energy and space efficient, and there's a lower capital expense, so lower upfront cost. When to use an intensifier pump? So there's some benefits. And with a 60K intensifier pump or intensifier pump in general, you have the ability to swap a rebuilt intensifier without stopping production. And we actually offer some programs called Flow Care Complete, and they're great. You're able to, we basically rebuild these intensifiers for you, and we send them back to you so that you can swap those. We also have programs that are a step up where we actually send a technician in there and we swap those intensifiers, and you're down for 20 minutes while we do that. So there's some really good options for intensifiers, but maximizing uptime and not stopping your production is a big part to go for an intensifier. The simplified and less frequent maintenance, as we saw in those pictures of the direct drive and the intensifier in the videos, there's less, seals. There's only 2 sets on an intensifier versus 3 sets on a direct drive, and maintenance can be done a lot smoother. So better suited for applications with significant on-off cycles, as we talked about. The intensifier's ability to stop shifting. And then reason to go for a 94K, you get all those same benefits of the 60K, but it's faster cutting, so you're going to get more parts off the table per day, and lower operating costs due to decreased abrasive use. So you're going to lower your operating costs, you're going to get more parts, and you get all of the same benefits of having an intensifier as you do with 60K. So ideal for high production, fast turnaround environments and applications where precision parts are required. So that's kind of geared towards our 94K pump. The 25% smaller diameter stream, again, enables, really tight corner radiuses, up to, commonly is 15 thou inch radius, but we can get smaller with those too as well. Easy maintenance, fast foolproof maintenance, special high-speed pressure loading tool. This allows you to easily seat and install your I can't think of the word right now. You can't easily seat and install your seals in your intensifier. And here we have a picture of that pressure loading tool. This basically enables that. So advanced materials, foolproof design, diagnostic sensors that allow maintenance to be performed at regular intervals that maximize uptime and ease scheduling of service. So, these intensifiers are built to maximize uptime. You're going to reduce your intervals of maintenance and the ease of scheduling service. Again, we can come in and do all that maintenance for you on the intensifier. We can set it up to where we ship you an intensifier and we install those. There's a couple different ways we can set up the FlowCare Complete program.
Yeah, and so kind of like what Evan's referencing here with the FlowCare Complete programs, we have a number of different programs in place at Flow. There's all this focus on the pump, and that's kind of the heart of the system. And you want something that cuts faster and is more productive, or a lot of people do. Not everyone needs that, and that's why we make all the different styles of pumps. But for the guys that just need that machine to run, the maintenance for any machine, tool, a vehicle, kind of anything, how do you handle that? A lot of people prefer to handle that on their own, and that's why we make these things simple to maintain on your own. You want to get a guy trained up. It's not overly complicated. You've got someone who's competent. They can certainly maintain this machine themselves. What we found more and more over the last handful of years is that guys are really kind of wanting to get away from that. They don't want to have a guy on staff who, needs to be trained on rebuilding everything. And then if, for whatever reason, he takes a job somewhere else, or he's gone for the day, or he's sick, or he's out on an install somewhere, no one knows how to maintain the pump. So what we've done is we've put some programs together where we'll actually handle all of your maintenance for you. So this graphic on the screen is kind of speaking to our intensifier exchange program. With the direct drive pump, you've kind of got to stop production, take it all apart, rebuild it, which is fine. The guys that are only running a few hours a week, that's no big deal for the machine to be down for half a day while it gets rebuilt. Now, when you're on more of the production side, that's a big deal to take that machine offline for half a day. So we've got a program where we will totally rebuild an intensifier and we'll ship it to you. And now your guys, kind of after they stop cutting a plate of material while somebody's unloading and reloading that guy just walks over, 4 bolts, 2 high pressure lines, 2 low pressure lines. He takes the entire intensifier unit off. He takes the one we ship down and just bolts the whole unit up, connects it. And by the time the guys have the plate loaded, they're back running production again. And then you ship the old one to us and we rebuild it for you. So that's one kind of option, but we've got a few different levels. So that'd be kind of more on the standard level. Then we have Plus as well as Complete. So, on the far side, we've got programs where you don't even have to have a guy who can take off those 4 bolts. We're going to come in and handle that stuff for you. We're going to, test your water quality, understand how many hours you're going to run in a day, how many shifts you run, and we're going to set some predetermined service intervals, and we're going to pre-schedule guys from Flow to come out there, They're going to swap out your intensifier. They're going to inspect your machine. They're going to have a box with them when they show up that has all the parts you're going to need from then until the next service interval, to where you don't need to worry about ordering parts. You don't need to worry about stocking parts. You don't need to worry about, do we need to have someone rebuild that pump? Do we need to order another intensifier? You just focus on your business, make your money, and be as profitable as you can be in your industry that like the back of your hand, and just put it on flow. We'll maintain the whole machine. The thing's just going to get installed and it's going to run. And again, we've got everything from, you can just buy some parts and maintain it yourself. A lot of guys love to do that. We got guys, just sent me that rebuild unit. We're not afraid to bolt that thing up. No big deal. And we got guys that say, I don't even want to touch this thing except when I'm taking my parts off of it. And so we're really set up to kind of accommodate people regardless of what their demands are. So all this stuff, we're talking about pumps and horsepower and how fast a particular 1/4-inch aluminum part cuts and all these things. But everyone's situation is different. You've got a certain amount of floor space available, or you've got a certain amount of parts you need to cut. And maybe you're not really sure. Yeah, maybe I do need this thing to run 2 shifts. If that's how long it takes to cut 300 of my parts, maybe we'll find that cutting 300 of your parts takes 2.5 hours, and a 60,000 PSI pump will more than keep up with your demand. We've got guys spread across the country like Evan and I, and, we can talk to you on the phone. We can get on a one-to-one video conference. We can come out and visit you in your shop. But it's really about figuring out what it is you need to do. What accuracies do you need your parts to be? What kind of material are you cutting? What kind of throughput do you need? What budget does everything need to be within to make sense for your business? Where does it need to go? How much power do you have available? All these things. We really want to kind of get that dialed in. And maybe a simpler way to even do that, we've got a technology center with our 100s, 200s, 300s, 500s, and 700s and nanojets all set up at our corporate office, where we'd be happy to host you. I know traveling is difficult now, so if you can't fly up there in person, you can ship some material. We'll ship some material up. We'll ship us some material, send us your file. We'll cut your part. We can even cut it on a couple of different machines or with a few different parameters, and ship your parts back to you and just show you, hey, if you bought a Mach 100 with a 60K direct drive pump, here's what your part would look like. Here's how long it took to cut. Here's the operating cost. If you did the same thing on a 94K pump, here's what your part looks like. Here's your operating cost. Here's how long it takes to cut. You can, of course, weigh all those options along with what the machine pricing is, and really kind of get everything dialed in. So these webinars are great, but it's just kind of like dipping your toes in the water. We'd really encourage you, reach out to us and engage us. That's what we're here to do. We really want to kind of get all your questions answered and help you understand what the right machine is. And we have a lot of guys that we talk with. It's, a Waterjet's a big purchase. A lot of times it's the biggest purchase someone's made for their shop. And, I've been with Flow 15 years. Evan's been around a long time. So, we have a lot of conversations with people where you talk to them, a year and a half later, they're getting closer. They talk to us again. 8 months after that, they buy the Waterjet. So, this isn't something where you need to be ready to buy this thing to reach out to us. If you've got some general questions, or you're thinking about buying a Waterjet, or you're putting together a business plan, reach out. That's what we're here to do. And we really want to help you out. And we really want, to partner with you. I mean, we invented this technology. We're far and away kind of the largest company in the kind of niche market of water jet cutting. And, we've been able to do that by really partnering with people. We got guys that talk to us for years before they buy a water jet. Then they buy a water jet, they buy another one 15 years later. So we really want to, we make every pump. We have all the different machine models. It's really about just helping you out and figuring out which machine is going to best suit your needs. And then, let's partner together, get you a machine that's going to, make you some money, solve your problems. And, we just want to help you out however we can. So hopefully this has been helpful. Steve, I know, has some things he wants to cover kind of here at the end. And so I'll hand it back to Steve.
Great, Jesse, Evan, thank you guys so much. That was perfect. And I want to lead into a quick segue about how big a decision this is here. Folks, thank you for your time and attention. If you can't stay for Q&A, we would love for you to just hear this a little bit about what special promotions we have going on, because to Jesse's point, it's a big decision. Sometimes it takes over months and months of dialogue with our application experts. And to help, especially in an economic environment like the one we're in right now, we want to make it as easy for you as possible, especially financially. So the first promotion that we have in market at the moment is about getting an upgrade on a new pump. So you saw that there are a lot of different combinations between systems and pumps and how to configure them on the basis of what your applications are. The offer that we would like to make available to you now is when you start to talk to one of our application experts about the system that's right for your needs, we're offering you the ability to upgrade to the next highest level performing pump at a substantial discount. This reduced price can be a huge savings on your investment overall, not just on what you pay out of pocket, but on the ROI. If you are able to use a higher performing pump, you're going to get better efficiency. So the savings really happens in two places. The second is what we call our 90-day no pay. We know that a lot of our customers do like to take advantage of a financing option. And at the moment, we're offering the opportunity for you, if you choose to purchase a new system, we can defer the payments on your purchase for the first 3 months of your loan term to help preserve cash flow in what we know is a challenging economic environment. So this has made a big difference to some of our customers, especially this time of year, who need to keep their business going and to help save cash flow. So we invite you to take advantage of that opportunity as well. And finally, our Waterjet trade-in program, Evan showed you an example of that as well, where a customer traded in an earlier system that they purchased from us to upgrade to a higher performing system. In this case, it's a little bit different. If you have an old system, no matter who manufactured it, as long as it's operational, we will work with you and give you an estimate on the value of your system. Again, no matter who made it, and we'll give you a credit toward the purchase of a brand new system from Flow. This has been a very popular offer that a lot of folks have taken advantage of because the value is really, really significant. We urge you to have a conversation with the application expert in your area and talk about any or all of these great opportunities. So with that, what we're going to do is move over to the Q&A portion. I see Jesse and Evan standing by. We did get a lot of questions, so if you don't hear yours asked, rest assured that we will get to it. If not immediately in the next 24 hours or so, we'll send out all the answers to all the questions, whether they're answered here or not. So the first question is sort of a group of questions piled into one, and it's about the wear and tear on a 60 versus 90K pump. And the questions are about, if I'm using this ultra high pressure 94K pump, is that intensity going to cause my parts to, wear out more often than they would on the 60K? And are they more expensive to replace? Therefore, would it be cheaper for me and easier to maintain if I just stick with the 60K Hyplex? Or am I going to kind of make my money back with the higher pressure system, even though there may be wear and tear? Can you maybe, Jesse or Evan, dive into that a little bit for us?
Yeah, I can speak to that. And it's a really good question. And so, one of the main things is when we went from 60,000 PSI intensifiers and we released our 94,000 PSI intensifiers, I mean, it's something we've been working on for, 10 plus years. And what we didn't do, we didn't just take a 60,000 PSI intensifier and turn the pressure up. Everything's redesigned. And so we're using, in some cases, stronger materials, different types of steel, different types of stainless, some exotic materials, but everything's designed to run at that 94,000 PSI. So as far as service intervals and part life and things like that, you would expect really comparable part life between, say a 60,000 PSI and a 94,000 PSI intensifier. Because we've got to use, some more exotic materials and different grades of, steels and stainless steels, There certainly will be some instances where if you really zero in on like the cost of an individual seal, a 94,000 PSI seal on itself, by itself, is going to be a little bit more expensive. Usually what you're trying to kind of get at with that question is, what's the overall operating cost? Is this something where at the end of the year I've spent so much more money on this 94,000 PSI pump? And that's just something that's not going to be the case. Certainly individual parts are going to be more expensive, but when you want to understand the operating cost of a water jet, and you step back and you kind of look at everything, I kind of referenced it earlier, but the big operating cost is garnet. So, spare parts, things like pump seals, those represent, maybe 5%, something like that, of your total operating cost. Whereas the cost of abrasive and disposing of abrasive is about 2/3 of your operating cost. So, an individual seal might cost a few dollars more, but the big part of your operating cost, the garnet, is going to be decreased significantly with the 94,000 PSI pump. So, your operating costs are going to decrease quite a bit with a 94,000 PSI pump. So it's just careful to keep all that stuff in mind when you start thinking about operating costs and what's more expensive or what's less expensive. The whole idea behind the 94,000 PSI pump is it cuts faster and it has a lower operating cost. I hope that answered the question.
Great, thank you, Jesse. So the next question, a couple of questions about flow care. The first question is, I have an old flow water jet, and I'm wondering, is it possible to add flow care to an existing machine? And as part of that, also, there is a question about an intensifier rebuild, and wondering if I have flow care, can you give me a rundown of what items are actually included in the intensifier rebuild? So kind of two separate questions, but both around flow care.
Yeah, I could take this one. So with the enrolling your existing Waterjet and Flow Care Complete program, we can definitely do that. We'd want to do an inspection and just get an understanding of where your pump's at currently. Again, we have a couple different levels of flow care. So we have one specifically around the intensifier, other one that provide additional consumable parts. So we want to make sure we get you the right consumable parts for your water jet, but we can certainly enroll you in a Flow Care Complete program for your existing water jet. It's actually pretty common. And in terms of what parts are included in the Flow Care program, for the intensifier portion of it, we actually take those used or spent intensifiers back and we inspect them. They go through a full inspection. We replace all the parts needed and test them and make sure that they're ready for use. And then we ship those back out. So whatever parts need to be replaced in that intensifier, if you're under the Flow Care program, we will, and those parts are all included. So we take care of all of that side of it for you. But again, there's other Flow Care programs like Flow Care Complete where we would, provide additional parts like mixing tubes, orifices, blastus, spray shields, filters, on-off, the rebuild kit. So there's a couple different options that you can choose from. But yeah, if you have any, if you want one specific to your setup, just, let any one of us know. We can definitely get you the answers on that and get you, pricing and all that.
Great, thank you, Evan. Jesse, this one is for you. I think it's a little bit of a follow-up to your prior answer on the 60K versus 94K, and this is from a small shop with a limited budget. The question is, they're eager to get off the ground and are interested in our point of view on whether it's more prudent for them to buy a 60K direct drive now, or wait and save money and buy a 94K intensifier. Big difference between those two pumps, obviously, but would love to hear your input on that.
Yeah, and so that's a really good question. A lot of it's kind of going to depend a little bit on your situation. My guess is if you're thinking about buying a water jet, and this is typically, what we'll see. So I'm kind of making some assumptions here, but I'm going to assume that you're outsourcing some water jet work now. And so what we've seen work for a lot of people, and kind of like in the example that Evan gave, if the money's not there for a 94,000 PSI pump now, a lot of times if you're already outsourcing, $2,000, $3,000 a month in Waterjet work, you're outsourcing enough to make the payment on a machine that runs at 60,000 PSI. And so, usually what's going to make the most business sense, if you pencil it out, certainly, you can reach out to us. We can get you all these numbers, the exact pricing on different machines and the different feed rates and things. But you'd probably find that the money that you're spending outsourcing would make the payment on a machine with 60,000 PSI. And if you find yourself 1, 2, 3 years down the road and you really need more throughput, then it's just a matter of upgrading. And that's why we have our trade-in program. And that's been a pretty common process. If someone buys a Mach 100 or a 200, and then, 1 to 4 years down the road kind of seems to be the sweet spot. Guys end up upgrading to a Mach 500 with a 94,000 PSI pump. So, I think you'd find that if you kind of run the numbers, it's probably going to make more sense to get a Waterjet now, stop outsourcing, get that efficiency. And if you get to the point where that can't keep up with production, that usually kind of lines up with having the funds to invest in a 94,000 PSI pump.
Great answer. And yes, just as a friendly reminder, even if you don't have a pump now, if you're actually shopping, now would be a great time to reach out to an application engineer here and understand how we may be able to upgrade you from a higher level performing pump that you may think you may not have the budget for, but depending on what your needs are and your budget, we may be able to work with you to get you into a higher performing pump. Let's see. So another question from a small job shop that is actually something that we get not infrequently. It's about noise. And sometimes we have customers who are working in limited space and have other things going on in their shops besides running a Waterjet. Can either of you, maybe Evan, this is a good question for you, talk a little bit about the noise levels as you move from one pump to another, and how can you rate those or rank them in any way, or just talk a little bit about that?
Yeah, so in terms of pumps and noise, you kind of have to look at it the whole scenario. The reality is that the cutting and the piercing are the loudest part of cutting with a Waterjet. So when you're in a shop and you're running a Waterjet, the pump is kind of just background noise compared to the actual cutting and the piercing. So we always recommend, if you're standing near a Waterjet, just general safety, you should have eyeglasses and then earmuffs on. But in terms of the pumps, yeah, I think that you won't really even notice the pump running in the background. At least I don't, and I think it's pretty common for most of our customers. I don't know if Jesse, you want to add on to that?
Yeah, I mean, and there's definitely, there's differences in the noises that the pumps make, and the direct drive pumps can be a little bit quieter than the intensifier pumps. But again, rarely, if you're in some situation where you have a pump room or something like that, and that's right next to someone's office, that's probably a pretty big concern. But in most Waterjets, you're going to find the machine and the pump are sitting right next to each other. And, like Evan said, even if the direct drive pump's a little bit quieter, the noise you're hearing is the piercing and the cutting. And if you have an intensifier pump that's a little bit louder, the noise you're hearing is still the piercing and the cutting. So, the pump is not the loud part. It's not what you're noticing when someone's running a Waterjet. It's the sound of the cutting. So that's kind of the loud part. But yeah, there are some different decibel levels of the different pumps. And that's kind of one of the benefits of the direct drive, is it can be a little bit quieter style of pump. And for some people, that's important. And that's one of the reasons we make them.
Great. So a couple questions, a slight shift in direction here. Talking about horsepower. So we have 30 horsepower versus 50 horsepower direct drive pumps. Can we talk a little bit about what the differences are and what the advantages are?
I mean, we kind of alluded to it a little bit, but you're going to cut faster with more horsepower. And, because more horsepower, you're producing a higher volume of water. A certain volume of water needs there's a ratio of kind of your water to garnet. So if you go up in horsepower, you increase your flow of water volume, you increase your abrasive volume, and you in turn cut faster. So, a lot of times what we'll see as well is like on a Mach 100, a Mach 200, you'll see a lot of pumps kind of down in that 30 horsepower range that are able to keep up with everyone's speeds. They're at 60,000 PSI pressures, and the lower horsepower does everything that someone needs it to do. We also have a lot of situations where the guys kind of at the 100 and 200, maybe they're renting a shop where they've only got, 70 full load amps available at 460. And that's a big consideration as well, is how much power do you have available? Because sometimes the guy only has enough power to run a 30 horsepower pump. So that's another good fit for a 30 horsepower pump. And if you're renting a shop, you don't want to spend a bunch of money running new power and getting new service to the building. If you own a shop, you may go ahead and invest to do that and be able to get to faster cutting. So, there's a lot of reasons you might go with a 30 horsepower pump as compared to a 50. And then, of course, we make 100 horsepower pumps. We've even got some big 200 horsepower plus pumps for unique applications, or guys that'll get a Mach 700 with, 2 bridges, 2 cutting heads on each bridge, and each cutting head has a 100 horsepower pump to it. So there's lots of different setups, and higher horsepower is going to cut faster than lower horsepower. And, it's just one of the ways you can cut faster. Typically, if the goal is just, maximizing production, that's when you start looking at getting into the higher pressure as well. But yeah, in the 100, 200 range, you might evaluate a 30 horsepower pump, a 50 horsepower pump. And that's something we can help you run the numbers on. We can get you a simple chart. Here's how quick this horsepower or this pump would cut. We can compare horsepowers and pressures and all that, so specific to someone's application. Just reach out. We'll get in touch with you and we'll answer that question in depth and make sure we're talking to you and getting you the information on the right pump for your application. And again, that's why we make the direct drive pumps, the 60K intensifiers and the 94Ks. If there was one pump that was right for everybody, we would just build one pump. The reality is there's just not.
Great. Thank you. Great answers, guys. Folks, the clock is ticking down. So unfortunately, we haven't had the time to answer all of your questions, but we will via email. Stand by just for 1 second, because if you haven't had a chance to get our contact information, it's here. We'll also follow up with the email as promised. And the chat windows are still open for a couple more minutes if you want to submit your name and contact information. If you'd like someone to reach out to you immediately, we will make sure that happens. Finally, thank you. We really appreciate your attendance and your interactive questions. We're hoping that this has provided a lot of value for you. Please join us for our next webinar, our next online trade show. It's on September the 22nd. It's going to be with our very special guests, as you may pick up on the hint there. We have a great partnership with our friends at Joe Gibbs Racing, and we will also be offering a very enjoyable giveaway to 10 lucky attendees. We will not be giving you a real car, I'm sorry to say, but we'll have some great materials for you that we think you'll like to have. So please register. Be on the lookout for our invitation and for our follow-up with everything we promised. And we look forward to seeing you at our next webinar. Thank you all so very much, and enjoy the rest of your day.
Thanks.
Thanks, everybody.